Hi, folks. Thanks for joining us today to learn about cloud threat detection with Security Command Center Premium. My name's Tim Peacock. I'm a product manager here at Google, and I look after our threat detection products here in Google Cloud. The talk today is going to cover Security Command Center Premium, but we're going to start with threat detection and start, once we get into the details, with a special announcement of something we've been working on for a long time. We're really delighted to be announcing. So first, I want to invite you to think not like you've been thinking, but think with portals. So in cloud, things are a little bit different. Things are a little bit the same. Things are a little bit different. The things that are the same is that our needs as security professionals haven't really changed. When it comes to protecting our corporation's data, keeping our applications secure, keeping things up and running, those needs haven't changed. And when it comes to modeling attacker behavior, the MITRE framework, well, doesn't change that much. We have the same tactics, but the techniques and procedures underneath, those look pretty different. There are some things in cloud that might be surprising. First, although we all got to feel really smart at conferences 2-3 years ago with little buttons that said, oh, the cloud's just someone else's computer, it's actually a lot more than someone else's computer. And in a sec, we'll talk about some of the surfaces that are present in cloud for defense and attack that we get to think differently about. Finally, each cloud is different. And I want to abuse Tolstoy by saying every cloud is different in its own way. So when it comes to what you know about a security model on, say, Azure or AWS, your security model in Google Cloud is going to be different. And it's important as you continue your journey into cloud threat detection, you work with a provider who knows their cloud best. And I think what you're going to see here today shows some of the unique advantages that we offer for teams wanting to protect their workloads in Google Cloud. So what does protection in cloud look like? Well, I think of it as having these 6 layers. On the left is identity. And what's different and so different about cloud as compared to on-prem defense is every action that happens in cloud is tied back to an identity. And so whether that's a human, a service account, you have an identity that made that change at the end of the day. Moving up the stack from identity is the API. In Google Cloud, we have a common API that underpins all of the changes happening, and instrumenting that API gives us a unique lens and a powerful lens for detecting how things are going in your cloud and what things might not be how you want them to be. In addition to all that, there are the managed services that we make available, whether that's BigQuery, Cloud SQL, the AI products, the cloud functions. There's a lot of things going on in cloud where we really can't point to, yeah, that's just a computer. It's something completely different. And securing it needs a different model than securing similar analog things on-prem. In cloud, we still have a network, and we'll talk a little bit about network layer detections that are available in Command Center Premium. We also have network layer protections available from our friends in the network security org. Finally, on top of all of that, we also have a compute layer, and the thing we're about to talk about has to do with protecting that layer. And then on top of compute, we also have Kubernetes, which is both a workload runtime environment as well as an orchestration layer. And having protection for both is really important as you move to cloud. So let's talk about what's new and exciting. After many years, we are super excited to announce virtual machine threat detection. Now, we've talked to a lot of teams about the challenges of protecting their workloads in cloud, and we'll get into some of those challenges in a second, but they boil down to a consistent theme of it's hard to protect workloads in cloud for a lot of different reasons. And we thought, what if we tried something different than what we've tried for the past 20, 30 years when it comes to protecting compute? So rather than build the next greatest agent and try to deploy that to all of your endpoints, we took a step back and thought about what do all of the compute instances in cloud have in common? We realized that they all run in Google Cloud on top of the same hypervisor. And so rather than try to embed agents into all of the virtual machines, we instead have instrumented the underlying hypervisor that makes virtual machines possible. Now, on the left-hand side of this image, you can see 3 happy little virtual machines with their access to underlying shared resources mediated by the hypervisor. In the middle, you can see how the hypervisor maintains a mapping of the contents of physical memory pages back to the virtual machines that own them. Finally, on the right-hand side, you can see how we've given ourselves the ability to grab the contents of memory at runtime, pull that into our analysis engine, and then deliver security results out to Security Command Center. Now, today we've built this capability specifically to detect crypto mining in Google Cloud. The Google Cybersecurity Action Team recently released a report that said 86% of compromised cloud instances are used for crypto mining. We thought, let's tackle the biggest problem first And so the first release, which is now in a public early access, and you can turn it on in your Security Command Center Premium console, is focused very much on detecting cryptocurrency mining in your cloud environment. In the future, we've got a really exciting roadmap of things that we want to do next with this, but we're going to start for the next couple of months, focus very squarely on the problem of how do we help users detect crypto mining when it's happening in their environments as quickly as possible. Now, we know that protecting your trust in Google Cloud is just as important as protecting your workloads in Google Cloud. And to that end, Google offers two complementary products. In addition to virtual machine threat detection, we also offer confidential compute. Confidential and VMTD are kind of complementary technologies in that VMTD gives you protection against outside-in compromise, and confidential compute gives you mathematical protection baked into the silicon that Google doesn't have a way of accessing your memory. So how do these two technologies work together? Well, they don't. In truth, we've designed specifically protections into the hypervisor that will not let us access the contents of memory for a confidential node. So if you're running confidential compute workloads, you've made a decision that your most important priority is preventing Google insiders from accessing the contents of memory at runtime. In that world, it doesn't make sense to try to deploy VMTD against it, and so we simply don't. Conversely, you might decide that you're not as worried about that as you are about outside-in compromise, and so virtual machine threat detection might be the right choice for your workloads. It's up to you, and here at Google Cloud, we believe in giving users that power. Now, as we've been developing this, we've talked to a lot of different teams about the challenges they face in protecting workloads in cloud. And so I want to talk about 4 cases, 2 cases about technology, 1 case about org process, and 1 case about business design, where we think this kind of cloud-native workload protection is really differentiating and really powerful. The first case is ephemeral and scaled workloads. I talked to a lot of users that have a hard time with workloads that spin up and spin back down too quickly for their agents to get up and running, or to complete scans, or to even download their updates. And so in these cases, we've designed VMTD to be ready to go as soon as your workloads are, so that you're always protected when you're running in Google Cloud, regardless of how quickly you scale up or scale down your compute. In the second case, I've had security teams come to me and say, Tim, this other team wants us to run an agent, but we've already put a totally locked down network around our workload. How can we still protect these instances without having to open holes in the firewall for the agent to call back to its C2 or to get its updates or its management? And in this case, because VMTD is baked into the hypervisor, it doesn't require network connectivity out to the internet to give results to Command Center. Instead, we just make an RPC back to our own service and say, here's the threats we've detected. So there's no holes in your firewall to make this protection work. So there's the 2 technology cases. We also see a lot of cases where a security team is kind of like an umbrella, but the teams underneath, the engineering teams that own projects, operate pretty independently. And sometimes they run outside the rain shadow of that umbrella. This can be a challenge when an engineering team, say, doesn't use a required golden image or doesn't want to run an agent or doesn't even have the ability to get that golden image or run that agent. In this case, we've built VMTD to be enabled at the org level with declarative configuration where a security team can say, apply this to all these projects. And regardless of what the engineering project team wants or doesn't want to do, we take care of that deployment and make sure that their workloads are protected. Finally, we see a lot of businesses today taking advantage of the speed and scale and flexibility that cloud offers to build businesses where they run workloads that their users supply. Now, this might take the form of a community-driven CI/CD pipeline. This may take the form of a bioinformatics research arm. There's lots of organizations that are running user-supplied workloads without great visibility into what those workloads are doing. In those cases, VMTD is a great way of detecting and deterring crypto mining adversaries who show up and abuse those services. So VMTD is making possible cloud-native technologies, cloud-native organization patterns, and cloud-native business models. And we're really excited about what's going to come next for VMTD. Now, if you've watched our talks in the past, you've heard of ETD. This is the layer of protection that protects your identities, API, the managed services, and some of the network protection. ETD is, at its heart, a log processing pipeline that handles incredible cloud log speed and scale of logs, where our median end-to-end latency from an event happening to a finding being available is about 5 seconds. Our 90th percentile latency is a lot slower at 8 seconds. So what are we looking for with this? Well, we'll talk in a couple of slides about specific finding types, but ETD is really keenly interested in protecting your identity layer, both to detect account compromise, but also to detect ways that identity can go wrong and be misused by adversaries, either to gain persistence or inject access through what MITRE terminology would be credential access or initial access. Finally, we're really stoked about some of the private integrations that we're undertaking with event threat detection. In addition to accessing the user space logs that users have access to, we're also now integrated with Google Groups to detect when we see an external member joining a group which has permissions in your org, or that group's permissions changing to be more accessible than it should be. You can expect to see more changes like this in the future, and we're really excited about what comes next for ETD and deepening its integrations with Google Cloud. Finally, like the rest of SCC, ETD has historically been a fully managed service where the rules are what you get. We're currently in a private preview and trending very quickly towards a public preview of configurable modules, where in addition to the things we know to look for, we're going to make it possible for you to help us know what to look for and give us configuration that will drive more findings that are more relevant for your organization. So we're really excited again about what comes next for ETD. And finally, one of the things that's great about it is not only are you getting what we think of as leading protection, you're also getting what Google thinks of as leading protection. 3 years ago, when we started this team, it was built just for cloud customers. About 2 years ago, Google, in its use of Google Cloud, selected ETD as the protection provider for Google Cloud. And we're really delighted about our collaboration with internal security. They give us a lot of great insights about interesting techniques we see adversaries attempting and using in attacks on Google Cloud, whether those adversaries are internal red team simulations or outsiders. And so you're benefiting not only from the expertise of the event threat detection team, but the expertise of Google's security teams securing Google when you use event threat detection. Finally, I want to talk about container threat detection. Kubernetes brings new challenges to security teams. It's a new operating environment, but it's also a new way of thinking about application delivery and deployment. So when I think about Kubernetes security, I really think about there being 3 pillars. First, are my applications secure to deploy? Meaning, is my infrastructure in the correct configuration? Second, are they built securely? And third, are they secure at runtime? And now Google Cloud has pre-hardened Google Kubernetes engine. We've pre-hardened the container optimized OS, which we recommend is the base operating system for your Kubernetes worker nodes. And finally, we have things like our CI/CD pipeline and binary authorization to secure the deployment part of that security journey. Container threat detection, which is a built-in service from Security Command Center Premium, secures that final pillar of, are my workloads secure to run? We didn't want to build, again, an AV or EDR solution here. We instead looked, what are the fundamental assumptions we make when operating in Kubernetes land as opposed to traditional server land? One of the things we saw is that users should execute what they trust coming out of their build system, and they shouldn't be introducing new binaries or linking new libraries once a container image is built. This gives us an awesome way of having very high recall detection of new malware that's introduced to a workload after it's been built. In this case, we look for the introduction of added binaries and their execution, or the linking and loading of new libraries. In addition to those 2 detectors, we have a reverse shell detector, and last fall, we recently launched a malicious bash script classifier. Now, detecting malicious bash scripts is a kind of hard problem. It's a very extensible Turing-complete language. And what we did here is, rather than write a whole bunch of higgledy-piggledy rules, we instead trained a machine learning model on 2 corpora of bash scripts. The first corpus of bash scripts we got from public GitHub repositories, and the second we got from a source I'm contractually prohibited from naming that we have good reason to believe is predominantly malicious. We trained an NLP model, tuned it up, and we've been really happy with its performance since we introduced it. Not only are we seeing an extremely low false positive rate, we're also seeing recall of campaigns against open source and popular packaged software that we don't think we would have detected otherwise. So we're really delighted about our use of machine learning to increase our recall. At the same time, we wanted to use machine learning to increase our precision. And so in addition to detecting things using machine learning, we're also now using machine learning to suppress false positives. And so we know that the concept of saying, thou shalt not run new libraries has some issues with it. And so to that end, we've introduced machine learning to help us realize when our existing false positive coverage is not enough to take all of the noise out of the system and help us expand our coverage against known noisy workloads and reduce the work that analysts have to do sifting through on their own. Like the rest of SCC, KTD has been designed to minimize its not only compute impact, but also its DevSecOps impact. It's, again, a managed deployment where you have, as a security team at the org level, declarative configuration. You say, protect these clusters. We say, you got it. And we handle the deployment and upkeep of our daemon set, which is deployed on the cluster. The daemon set serves as the interface to our Linux security module. A Linux security module that we've included in the cost-based image gives us kernel-level insight into what's happening with your workload, whether those are file events, network events, process events. It also gives us a plane of visibility, which is below where a lot of adversaries will initially get user space execution. So we believe we have a fairly durable and robust way of instrumenting your workload. The LSM gives us kernel-level insights. The daemon set not only gives us a secure pipe between the LSM and our backend detection plane that runs on our compute rather than yours, it also makes us container aware. And so KTD combines the best of both worlds. You get kernel level visibility with user space container awareness to give you highly robust, powerful detection of the most common threats that we see in Kubernetes workloads. A few examples of what we're looking for. Now, I'm not going to talk through all of these, and you can read about them on our docs, but I want to highlight just a couple of things here. One, on the execution column, I talked about the bad bash script detector. I talked about the crypto mining detection with VMTD. On the persistence side, previously, event threat detection did a lot of work on the identity side to detect persistence. There's two additional finding types here that you may not have seen before, added SSH key and added startup script. These are looking for some of the advanced persistence approaches we've seen applied to GCE instances. On the privilege escalation side, we've been working really hard on a couple of user entity behavioral analytics detectors to find not only when users are coming from new geographies or service accounts from new client libraries, but also profiling when service accounts, after a period, start to use a new API. It's a very common sign that a service account has been compromised and is up to no good. Service account protection is absolutely crucial to the security model in Google Cloud. We're really excited about what's going on there. Finally, on the exfil side, we've been making big investments in not only increasing our depth of coverage for BigQuery data exfiltration, but also protecting Cloud SQL. So you can expect to see more across the board as the teams continue to develop new capabilities over the coming months and the rest of the year. Finally, security doesn't end with detection. You need to have investigation and response. To that end, Security Command Center is integrated with Chronicle, where with one click, you can pivot from a finding in Security Command Center to that same threat finding inside Chronicle, where they've built beautiful, really powerful cloud-specific investigatory pivots off of those findings to help security teams quickly and efficiently diagnose what's going on, troubleshoot, and get to the root of problems. Security Command Center in whole has 4 pillars of value. Today's talk is really focused on this third pillar, the threat detection pillar, and that's what I'm most passionate about, but it's only one piece of the puzzle for security teams. And so quickly with our time remaining, I want to talk to you about the other 3 pillars of value and how they all come together in Command Center. First, they say you can't manage what you can't measure. You certainly can't secure what you can't see. And so to that end, the first pillar of value and really the foundation for all of Command Center is our asset visibility. One of the beautiful things about cloud is that teams can spin up resources at a scale and speed unimaginable before. One of the scary things about cloud is that teams can spin up resources at a speed and scale not imaginable before. And so to that end, we've built asset visibility into Command Center as a core piece, not only to help teams in the security org know what's going on, but also to take teams in the security org out of saying no and into a mode of visibility and oversight without having to say no. And so we're really excited about not only the technologic possibility that this opens up, but also the org dynamic change that this makes possible as well. Command Center has a robust suite of risk management capabilities, from detecting platform misconfigurations up to operating system and web app vulnerabilities. And we also know that all of these efforts are not valuable if you can't prove to third parties and internal second parties about the value of what you're doing. And so I'm going to pop through each of these other pillars real quick and give you a little bit of a deeper taste of what I'm talking about. First, asset visibility. Like I was saying, we think this really heralds a way for security teams to change their operating model. And in cloud, we know that things change rapidly. And so the cloud asset visibility in Command Center not only gives you a picture of the world today, it also allows you to go backwards in time and see your assets at points in the past. The team is still working on helping you see things points in the future. When that happens, we'll have quite a party. On the platform and software misconfigurations and vulnerabilities, we're really excited about this today, in part because Security Health Analytics, our platform misconfiguration tool, now operates in real time for the vast majority of its issue types. And what this means is, rather than having teams with a checklist mentality of seeing, okay, is my firewall still good? Was it good 30 days ago? You can know instantly when something changes with your firewall or your other configurations. And this really heralds a sea change in the cadence that teams are able to operate. And so this is a case where we think security teams can really get inside the decision-making loop of an adversary and respond to issues faster than ever before because they're detecting them as they happen. And that's all possible because this is a native integration with Google Cloud where we consume the feed of changes that are happening in real time and produce findings about those issues in real time. And this is what makes me so excited to be a part of Command Center, because we are really changing the game when it comes to what's possible for securing your cloud assets. Now, we ran through the threat detection pillar in depth, so I'm going to skip that for now and instead talk about reporting and compliance. We all have our reporting and compliance challenges, and we all know that it's critical that we be able to show to our auditors what we're doing is meaningful and valuable. And so to that end, we've built our finding types not only to be real time, but also to pivot against the compliance standards that they're relevant to. And we think this is a really powerful capability. Users love that they don't need to go through and do checklist compliance. They can instead just download a report of how well they've done over the past month. That's Command Center in a 20-minute nutshell. 4 pillars of value. First, asset visibility and reporting. Second, comprehensive risk management with platform as configuration, CVE, and web app vulnerability detection. Threat detection at every layer of the cloud threat stack from identity up through your Kubernetes runtime. And finally, compliance reporting, so you can prove to people that what you've done is valuable. If you want to get started and learn more, you can check us out on our docs page or navigate to Command Center in the console and contact your sales team to get started with a trial and learn more. So with that, I want to thank you for joining us today, and I look forward to seeing your questions in the dory. Thank you.